Today on How It's Made. Wheel loaders. He ain't heavy, he's my snowplow. Vegetable oil. You'd be hard-pressed to make salad dressing without it. Hand tools. Getting a handle on repairs and renovations. And cotton swabs. Hear ye, hear ye. They're big, they're bulky, and boy, can they move stuff. Wheel loaders are drivable, heavy machines. You see them on construction sites moving dirt, at landfill sites moving garbage, and in the winter, you see them all over, clearing large quantities of snow. They start by assembling the 100-odd steel components that make up the front frame. These parts are so heavy that workers have to use industrial-strength magnets to move them. Take note of those pieces with the holes in them. We'll come back to them later. Workers measure and mark exactly where they'll weld the front frame parts together. You might not think precision is all that important when it comes to building a 20-ton hunk of machinery, but it is. Being just a couple of millimeters off can cause major problems. The preliminary welding is done by hand. Workers tack the parts together. They do the same with the 100-plus steel parts that make up the loader's three other sections: the rear frame, the driver's cab, and the moving arm at the front, called the boom arm. Once the manual welding is completed, robots take over to do the major welding. They solder about 90% of the wheel loader. Now that the front frame is solidly fused, it undergoes a final machining. Remember those parts with the holes in them? They're what enable the boom arm to move. A computerized sensor now measures those holes and calculates how to cut them to the exact specifications of the engineering design. The computer then guides the machining tool to tailor the holes to spec. First, a preliminary cut. Then, after some oil lubrication, the final cut. When this operation's complete, the front frame will join the other sections at the paint shop. After painting, workers begin the final assembly. They position an axle under the front frame and another under the rear. Then they affix the frames to the axles with heavy-duty bolts. They mount the diesel engine and transmission in the rear frame. After assembling the cab, they install it onto the rear frame . Then connect the wiring for the controls. Now comes the boom arm. Remember those front frame parts with the holes? Workers line them up with holes on the boom arm, then insert giant steel pins. This creates a pivot mechanism, enabling the arm to move up and down. The moving parts must fit together snugly, but not so tightly as to restrict movement, which explains why welding and machining precision was so crucial. Once they've tested the boom arm's hydraulic lift system, workers install the tires, which are almost 2 meters tall. Using a specially calibrated torque gun, they bolt the tires to the rim. 32 bolts in all. The wheel loader is fully assembled. Now the boom arm can be equipped with a forklift, a broom, or a big shovel called a bucket. Vegetable oil is a fat extracted from the fruit or seeds of certain plants, such as corn, canola, cottonseed, safflower, sunflower, or soybean. There are various ways to extract the oil. The method we're about to see is called cold pressing. It all starts with seeds, in this case, a dark variety of sunflower seeds. Cold pressing yields less oil than other methods, so it's usually just smaller specialty companies that use the process. The big vegetable oil makers tend to use solvents and high-pressure, high-speed presses. That's much more productive, but it also generates heat, which darkens the oil and diminishes its flavor and nutritional value. These seeds, shells and all, will go through this low-pressure press. The temperature inside is kept below 40 degrees Celsius, hence the term cold-pressed. The press operator has to carefully monitor and adjust the speed, pressure, and temperature, because keeping a press cool is no easy task, given the heat that mashing seeds naturally generates. The pressing mechanism, the screw press, is made up of several sections, so they can shorten or lengthen it according to the type of seeds they're pressing, to allow for more or less room for the seeds within the chamber. One 100 kilograms of seeds per hour go through the press, producing some 38 liters of oil. Low volume, but high quality. The seed residue, called seed cakes, is later sold for animal feed. Now, though, it's key to monitoring temperature. If the seed cakes are too warm, that means heat is building up and they have to open the exit wider to reduce the inside pressure and bring the temperature down. Once the oil is extracted, they pump it through a filtration system. These cloth filters allow the oil to pass through, but any remaining seed residue gets caught in the fibers. The oil runs through the filters repeatedly until it becomes clear. Mastering the art of cold pressing takes a lot of know-how and experience, but it results in oil that's healthier and tastier. Cold-pressed oils made from other seeds pose different production challenges. Flaxseed and hemp seed are extremely sensitive to heat, so workers have to cool the press during the process to offset the heat that pressing generates. Canola, on the other hand, isn't particularly sensitive to heat, nor is sesame. All natural, no preservative vegetable oils like these have to be babied because exposure to air makes them prematurely spoil. Plastic isn't airtight, so they bottle these oils in glass. Dark glass to block oil's other enemy, light. They seal the bottles with a flow control cap. Without preservatives, sunflower, canola, and sesame oils have an 18-month shelf life. Flaxseed and hemp seed oils have to be refrigerated. Even then, they go bad after just a few months. You don't have to be a do-it-yourselfer to own a few basic hand tools. Even the renovationally challenged are likely to possess a hammer, a screwdriver, maybe even a pair of pliers. If not in a toolbox, then at least crammed into a messy drawer somewhere. Here's a look at how some hand tools are made. Every screwdriver and chisel has to have a handle. This factory makes handles from acetate, a synthetic resin. These 2-meter-long acetate bars come in many colors and contours. They arrive here ready-made. Workers load the bars onto a machine that feeds them into a lathe. As the lathe spins, an automated knife cuts one handle after another, rounding off what will be the top of the handle. Then it sculpts the other end. Then a drill makes the hole into which they'll later insert the blade. All this takes just a few seconds. Now the handles travel to their next stop, the dipping machine. Acetate becomes dull and opaque when cut, so the machine dips them in acetone, a chemical solvent. This brings back their translucence and shine. It also removes any acetate shavings stuck to the ends. Here's what the handles look like before the acetone bath. And here's what they look like after. The handles air dry on their way to the next stop on the production line, printing. The hot stamp printer works in conjunction with an ink ribbon. It applies about 25 kilograms of pressure, engraving the product code and brand name, while the heat, about 70 degrees Celsius, transfers the ink from the ribbon into the engraved lettering. The handles are finished and it's finally time to insert the blades. In this case, Phillips head screwdriver blades. Blades are made of carbon steel. An automated machine forces them into the handle with about 36 kilograms of pressure. Workers insert chisel blades manually in order to protect their sharp edge. At the same time, they top the handle with a steel cap to give the chisel extra striking power. Another common hand tool is the drywall square, also known as a T-square. They cut two strips of aluminum. The first 1.4 meters long, the second 56 centimeters long. Then they apply the markings by silkscreen printing. Next, they use a bending machine to fold over the top edge of the piece that will form the horizontal part of the T. This will allow the tool to hook onto the edge of a drywall panel. Finally, they rivet the two pieces together. The drywall square is finished. Factories can alter the size of the tools they produce to meet their clients' specifications. Standard screwdrivers have handles 9 to 11 centimeters long, with blades 4 to 20 centimeters in length. Some screwdrivers, on the other hand, have extra long blades, while stubby screwdrivers have short handles for getting into tight places. Then there are those skinny pocket screwdrivers and precision screwdrivers for jewelers and electronics technicians. All of which proves there's a tool that's the right size for every job. We use them to apply and blend our makeup. We use them in a pinch to pry dirt out of tight crevices. And, of course, we use them to clean our ears, though doctors say to never insert them into the ear canal. Cotton swabs are just one of those little things that are really handy to have around the house. Cotton swabs were invented in 1926 by one Leo Gerstenzang, a Polish-born American. He got the idea from watching his wife clean out their baby's ears using a flimsy toothpick stuck into a piece of cotton. Leo set out to design a safer device. He took a thicker wooden stick, wrapped the ends with cotton in such a way that it wouldn't come off and get stuck in the ear. The Leo Gerstenzang Infant Novelty Company marketed this invention under the trade name Baby Gaze. Many cotton swab makers also produce cosmetic pads. Both start with bleached cotton. It arrives at the factory compressed in large bales. The cotton first goes into a machine called the feeder. From there, into a machine called the opener, which shreds the bales, pulling the cotton fibers apart. Next stop, the carding machine. Its large rollers comb the cotton fibers out. Then, guided by weight-detecting sensors, it produces a uniformly thick ribbon of cotton called a web. This web is now ready to be processed into either cotton swabs or cosmetic pads. To make pads, they layer several webs. Just how many, though, is a closely guarded company secret. And so is how much pressure they apply to those layers to compress them. This secret recipe of layers and pressure is what ultimately determines the weight of the pad. The heavier it is, the higher the quality because it's thicker. The now compressed layers of web go through a machine called the slitter. It cuts the wide roll into several narrower rolls called header rolls. Each header roll then goes through a machine that stamps on a quilt-like pattern purely for aesthetics. Finally, using a punching die, they cut the pads. On this production run, each pad weighs about 0.7 grams, but the factory can produce whatever weight the client requests. The cosmetic pads are ready to be packaged. This client wants them in bags of 100. The blue light shows the workers the 100 pad cutoff point. To make cotton swabs, the initial web is divided into 4 narrower webs, each weighing 1.5 grams per meter. Each narrow web travels through a funnel, which transforms its shape from flat to round. Then it coils into a barrel. The swab-making machine then takes the cotton strands from 2 barrels at a time, feeding a line of cotton to each end of the stick. Like the cosmetic pads, the amount of cotton per stick varies according to the client's specifications. The stick feeder prepares the sticks. Then, as we see here in slow motion, the machine cuts the cotton strand and rolls a piece onto both ends of the stick simultaneously. Just prior, a heating device melted the tips of the plastic sticks, so that the cotton would adhere. With wood or cardboard sticks, they glue the cotton on. The finished swabs are sprayed with an antibacterial solution. Here's that action in slow motion. And now, in real time, 2,000 swabs per minute. Sensors detect any defective swabs and automatically toss them off the production line. If you look closely, every so often you'll see one missing. Finally, a robotic arm grabs the exact number of swabs per box, again determined by the customer's specs, and packages them. The company's lab does spot checks on its swabs to ensure that the antibacterial solution is working and that the products are germ-free. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.